Hello, this is Mr. Stansbury. I'm going to take you through the 12G assignment. All right, so first thing we start with is number 1 here. It says find this series of numbers, the sum of the series, by adding them up. Okay, so let's add them up. We got 1 plus 5 plus 9 plus 13 plus 17 plus 21 plus 25. Put it all in our calculator and we get 91. Okay. And then it says add by using this formula here, right? So the S of n, so the S means the sum of our sequence here. S of n equals, really, and the n stands for the number of terms. And look, there's 1, 2, 3, 4, 5, 6, 7 terms. So really it's sum of the first 7 terms of the sequence should equal 7 over 2, all times the first term, that's what u sub 1 stands for, the first term, which is 1, plus u sub n, which is the last term, which is 25. So we get S of 7 equals 3.5 times 26. Okay, and hopefully that gives us 91. Let's check it out, see if that works. So we've got 3.5 times 26, and poof, we get 91. That's good. So S of 7 is 91, so that works. And then it says also use this formula here. So S of 7 equals 7 over 2, all times 2 times the first term, which is 1, plus the number of terms, which we figured out is 7, minus 1, all times the difference. So let's see, this is plus 4 over and over again, so our difference is 4, right? So sum of 7, 3.5, let's see, 2 times 1 is 2, 7 minus 1 is 6 times 4, so we get S of 7 equals 3.5 times 6 times 4 is 24, plus 2 is 26, which is exactly what we have there, so we know the S of 7 is going to equal 91 that way too. So these are 2 different formulas that will give you the same answer. It's both for finding the sum of a series. One of them just happens to be, this one is helpful if you know the last term, right? And then generally if you don't know the last term, this is the one that you want to use instead. All right. Let's take a look at some other examples here. We've got number 2. Find the sum of this here to 20 terms. So let's see, it's plus 4 plus 4. So these are arithmetic, which are going to be these first 2. This is the geometric one. And the reason, the way you can tell is D is the difference. So that's arithmetic. R is the rate. That's the geometric, so it's not going to be this one, it's going to be one of these 2. And again, we really only want to use this one if we know the last term, which we don't. So let's use this one. Okay, so for A, we've got the S of 20 terms, so S of 20 equals 20 over 2, all times 2 times the first term, which is 3, plus n, we know n is 20, minus 1, all times the difference, which is, we're adding 4 each time, right? So it's just going to be this here. So we got S of 20 equals 10 times, let's see, that's going to be 6 plus 19 times 4, right? And really we can just do this all on the calculator, so let's try that out. Let's do this. So we've got 10 times parentheses, and we got 6 plus 19 times 4. All right, and that should do order operations for us. So we get that the sum of the first 20 terms is 820. Okay, that's what we got. Yep. Okay, so that's A. Let's try B over here. So pretty much all these we're going to want to use this same formula here over and over again. Okay. Okay, so we've got S, and we got first 50 terms, so S of 50 equals the number of terms, 50 over 2, all times 2 times the first term, which is a half, plus the number of terms, 50 minus 1, all times the difference. So this is what, plus 2.5 is 3. 3 plus 2.5 is 5.5, so this is 2.5. Okay, and again, really, we can just put this just like it looks straight into the calculator, and away we go. So let's do this. 50 divided by 2, all times 2 times a half is just 1, so I'm just going to do 1 plus 50 minus 1 is 49, just to save myself a little bit of time, times 2.5, close. Oops, we got too many parentheses there. We don't need that. That last parentheses. Actually, wait, no, we do. 1 plus 49. I don't need this parenthesis here. Sorry. There we go. Delete that. And then we need this parentheses here. There we go. Okay, 3087.5. Oops. 3087 point, what was it, 0.5? 3087.5. Okay. For C, S of 40, because it's 40 terms, equals 40 over 2, all times the, 2 times the first term, which is 100, plus the number of terms, which is 40 minus 1, all times the difference. So let's see, this is minus 7. 93 minus 7 is 86. Minus 7 is 79. So this is all times negative 7, not subtract 7. So make sure you put that in parentheses. Otherwise, you'll think of just subtracting 7, or at least I would. So let's put this one in here. We got 40 divided by 2, all times 2. I'll even just put it in just like it looks. 2 parentheses 100. Close the parentheses, plus 40 minus 1. Let's just do 39. All right. Oops, I should have put, sorry, I should have put parentheses over there just to be accurate. Let's see, 39. Close the parentheses, start another parentheses, negative 7. And then double parentheses to close. Hit equals negative 1460. So sum of the first 40 terms all added together for that's going to be 1460. Okay. And then D, S of 80 is going to equal, 80 divided by 2, all times 2 times the first term, which is 50, plus the number of, sorry, let's see, no, it's the, number of terms, which is 80 minus 1, all times the difference. So let's see, we are subtracting 1.5, right? Yep, subtract 1.5 each time. That's our difference. All times negative 1.5. And then away we go on that one. Okay, so we got 80 divided by 2, parentheses 2, parentheses 50, or just 2 times 50, plus parentheses, we got 80 minus 1, which is 79, all times negative, don't push the subtract, make sure you push the negative, 1.5, double parentheses, and we get negative 740. Okay, so that's what the sum of the first 80 terms on that one would be, right? Negative 740. Yep. Okay. Moving on. So now this one here, find the sum of these terms. Let's see. We're adding 3, 3 each time, and we don't know how many terms there are, but we do know the last term. So this is the u sub n. So that's where we're going to want to use this formula here instead of that one, right? And again, this is if it was geometric, but it's arithmetic. Okay, so for A, we're just going to do number of terms. Ooh, that's what we have to do. We have to figure out how many terms it's going to be. So that's what makes this one a little trickier. In order to find what term this is, we're going to want to use our u sub n. This is our original geometric sequence, general form, and that's u sub n equals u sub 1 plus n minus 1 all times the difference. And what we're going to want to do is plug our info that we have here into this, just so we can figure out the n term, because we need to know what the n is here in order to find the sum. Okay, so we've got u sub n, except for, let's see, what we want to do, instead of plugging in u sub n, instead of writing u sub n, we want to plug in u sub n. So that's, we want to know when this is going to be 101. We know the first term is 5. We don't know the number of terms, but we do know that the difference is 3. Okay, so we get 101 equals 5 plus, and now we got to distribute that 3 to both of these. That's 3n minus 3. Right, so we get 101 equals 3n plus 2. So we subtract 2 from both sides. 3n is 99 over here, divided by 3. And we get that n is 33. So that's the 33rd term for, excuse me, 101 is the 33rd term of that sequence. So now that we know that, we can plug that into this nicer formula here. So we do the sum now of the first 33 terms is going to equal 33 over 2 all times the first term, which is 5, plus the last term, which is 101. And we plug that in, and away we go. Okay, so we get 33 divided by 2 times, let's see, 5 plus 101 is just going to be what, 106? Okay, and we get 1749. Okay, for the first, 33 terms, because that's how long it's gonna, that's the 33rd term right there. Okay, let's try B then, and we're gonna have to do the same thing for this one here. So we're gonna want to plug in u sub n equals u sub 1 plus n minus 1 to the d. We got to figure out what, how many terms, what term the negative 20 is. So negative 20 equals, first term is 50 plus n minus 1 all times the difference is, let's see, it looks like we're subtracting 1/2, right? So let's do negative 0.5. Okay, so let's bring out our calculator for that. Okay, I guess, no, we don't need it yet, do we? Negative 20 equals 50. And then negative 0.5 times n is negative 0.5 n, and then negative 0.5 times negative 1 is plus 0.5. Subtract 0.5 from both sides. Oh, actually, let's combine first. All right, so we get negative 20. 50 plus 0.5 is 50.5 minus 0.5 n. Now we can subtract the 50.5 from both sides. So we can do it all together. Okay, so that goes away, and we get negative 0.5 n equals negative 70.5. So then we just want to divide by negative 0.5, both sides. And we get n equals, basically, if we're dividing by, well, let's see, the negatives are going to cancel out and make a positive number. Dividing by 1/2, that's the same as multiplying by 2, right? So that's 141 is, oops. Can't really read the 1 with that now. We know that n is 141, but actually that's not what we want to end up with. That's just helping us figure out what to plug in. So now the sum of the first 141 terms is going to be 141 over 2 all times, let's see, the first term, which is 50, plus the last term, which is negative 20. Okay, so then we can plug that in, and that's going to be 141 divided by 2 times 50 minus 20 is 30. And we end up getting 2115. Right? Yep. Okay, so sum of this series here should be 2115. Okay, and then let's try C here. Let's see, we're going to do the same thing. U sub n equals U sub 1 plus n minus 1 all times the difference. So we know that the last term here is 83. We are trying to figure out what term that is. First term is 8, n minus 1. The difference here, we're adding 2.5 each time, right? Yep, adding 2.5, so that difference is 2.5. So we get 83 equals 8 plus 2.5n minus 2.5. So we have 83 equals 8 minus 2.5 is going to be 5.5 plus 2.5n. Right, so we're going to subtract 5.5 from both sides. And we get 2.5n is going to equal, let's see, that's going to leave us with what, 70, is that 77.5, right? Yep. And then we're going to want to divide by 2.5, both sides. Okay, so we take 77.5 divided by 2.5, and we get that that is the 31st term. 83 is the 31st term. Okay, so then we do the sum of the first 31 terms is going to be 31 over 2, all times the first term, which is 8, plus the last term, which is 83, and then away we go. Okay, so let's do that. 31 divided by 2, all times 8 plus 83. Or you could have just simplified the 8 plus 83 if you wanted to. Right, and we get 1410 and a half is the sum of the first 31 digits of that, 31 terms of that sequence there. All right? Okay, moving on to number 4, arithmetic series. So we're not going to use that. Has 7 terms. First term's 5, last term's 53. Find the sum of the series. So gives us first and last term and the number of terms. So this here is going to be nice and easy to use, right? So the sum of the first 7 terms of the series is going to be 7 over 2, all times the first term, which is 5, plus the last term, which is 53, right? And we're just going to calculate that out, and away we go. I like this one. All right, so we get 7 divided by 2, all times 5 plus 53, or just times 58. And that gives us 203. Okay, so first 7 terms of that sequence is going to add up to 203. Next one, 5, arithmetic series, not geometric, so we'll get rid of that. Has 11 terms. First term 6, last term's negative 27. Find the sum of the series. So we know the first and the last term, so let's use this one here. So the sum of the first 11 terms is going to equal 11 over 2, right? All times the first term, which is 6, plus negative 27 for the last term, and away we go. Okay, so we get 11 divided by 2, all times 6. I'm just going to go 6 minus 27. And that gives us negative 115.5. Okay. Okay. Moving on to number 6. Bricklayer builds a triangular wall with layers of bricks as shown. If the bricklayer uses 171 bricks, how many layers are placed? So first, let's just think of these as, these individual layers. So this is 1, 2, 3, 4 bricks, right? So we're adding one brick each time to get to the next layer, right? So that means it's geometric. Okay, we know that he uses or she uses a total of 171 bricks, so that's the total sum. We do not know the last layer, so I'm going to toss this one out and let's use this one here, because we know the first term, we know the difference, and we know the total sum, so then we can figure out the n with that. Okay, so let's do this. The sum, so let's use this here. So S of n, we don't know how many terms there are, how many layers there are. That's what we're trying to figure out. We're trying to figure out the n, so we got to leave the n as just n for now, n over 2. 2 times the first term, which is 1, plus n, which we don't know, minus 1, all times d, the difference, which is also 1. Now let's simplify this as much as we can, right? And we actually know what this S of n is. So instead of writing S of n, we know that the sum of this entire series is going to be 171. So let's plug that in. So we got n over 2, all times 2, and then distribute that 1 through, and it's just plus n minus 1, right? So we get 171 equals not n over n, but n over 2. Right, so that's n over 2, all times n plus 1, because 2 minus 1 gives us n plus 1. All right, now we got this fraction here. Best thing I think we could do here is if we multiply both sides by 2, it'll get rid of that fraction. So 171 times 2 is, 342. And then these 2's cancel each other out, turn into 1. We got n times n plus 1. So we have 342 equals, distribute that n through, and we get n squared plus n. Right? Now, we're going to subtract 342 from both sides. And that is going to give us 0 equals n squared plus n minus 342. So, we're going to want to factor this thing out. N and n, factors of 342 that have a difference of 1. Okay, so what we're going to want to do is just try to figure that out on our calculator. Right? Now, it's a big number, and we know that the two terms are only 1 apart. So maybe a nice little shortcut on this is to just say, okay, let's figure out what the square root of 342 is. Once I figure out where my square root button is, there it is. Second, if I take the square root of 342, it'll at least kind of give me an idea. Oops, I don't want that. I want the decimal answer, 18.49. So it's probably going to be 18 times 19, but let's check and see. So we take 342, divide that by 18, and we get 19. So we know that the factors are 18 and 19. These two factors have to add up to positive 1, so I know it's going to have to be positive 19 and negative 18. So n is going to either equal 18 or negative 19. Doesn't make sense really to have a negative 19, the negative 19th term, so let's go with n equals 18 on that one. Okay, so actually that's all it's asking for, is how many layers of bricks are going to be placed. It's going to be 18 layers of bricks. Okay. Okay. Let's move on to the next one, number 7. Each section of a soccer stadium has 44 rows with 22 seats in the first row, 23 in the second, 24 in the third, so forth and so on. How many seats are there in row 44? Okay, so let's see what we can do to figure that out. So maybe just to help, I'm just going to like start writing out our sequence here. So the first number is 22, and then the second one is 23, 24, so forth and so on, right? So we are adding 1 to each of these. So we know that it's arithmetic, not geometric. So we'll get rid of those. So for A, to figure out how many are in row 44, we're just going to want to do U sub 44 equals, and then this is just our U sub n formula, right? U sub n equals U sub 1 plus n minus, n minus 1 all times d, right? So U sub 44 is going to be our first term, which is 22 plus n minus 1. But actually our n is 44, right? Because that's how many, that's what we put in for our n there. Sorry, so that's 44 minus 1, all times the difference, which is just plus 1. So U sub 44 equals 22 plus 43, right? 43 times 1 is still 43. So U sub 44th, 44th row should have 22 plus 43, which gives us 65 total seats in the 44th row. Okay, for B, how many seats are there in a section? So now that's where we're going to want to use our S of n. So we want to know how many total seats there are. So that's the sum of all of the seats, right? So we know that the first row has 22, and we know that the last row actually has 65. So we can use this formula here. So let's use this one for that first part there. So we get S of, let's see, and then n is going to be the total in the section. So the sum of the first 44 rows are going to equal 44 over 2, all times the first, which is 22, plus the last, which we just figured out is 65, right? And then away we go. Let's figure that out. So we do 44 divided by 2, which is just 22 times 22 plus 65, or you could have just simplified that either way. Gives us 1914. So the sum in the first 40 all in one section is 1,914 seats. Okay, so that's the total. Now, how many are in the stadium, which has 25 total sections? So each section is going to have 1914. So really all we have to do for C is just do 1914 times 25, right? And that'll give us the total seats in the section. So multiply that by 25, and we get 47,850. 47,850 seats in the stadium. Okay. Okay. On to the geometric series stuff. We've got this here. Find the sum of the following series: 12, 6, 3, 1.5. Because if you notice this is minus 6. Then it's minus 3. So since it's different each time, we know that it has to now be geometric instead of arithmetic. Okay, so here's our formulas here again, but now we know it's not arithmetic but geometric, so it's going to have to be this one here. Okay, so for A, we're going to use the sum to 10 terms. So S, the sum of the first 10 terms of the geometric sequence. First term is 12, all times R, which is the rate. So to figure out the rate, remember we take the second divided by the first. So 6 divided by 12 is 0.5. 3 divided by 6 is also 0.5, so we know that's the rate. So we get 0.5 all, let's see, sorry, I shouldn't put that. It's just like this, 0.5 to the n, the number of terms, which is 10, minus 1 all over the rate, 0.5 minus 1. Okay, so now we should be able to put that stuff there into our calculator, and away we go. So We're going to want to take this whole top part divided by the whole bottom part. So to make sure that this turns out right in the calculator, I'm going to add some extra parentheses here to make sure that this works out right. Okay, oops, that's not what I wanted, sorry. Calculator, there we go. So we're going to do parentheses 12 times 0.5 all to the 10th. And then I'm going to push over here so that we are going to then subtract 1 from this here, not subtracting it from the power. Okay, so there's that. I want to double parentheses that, and I'm going to divide this all by 0.5 minus 1. Oops, and I want to put parentheses in here. So let's just do this. Divide by 0.5 minus 1 parentheses, and that should give us the right answer. 23.976. So let's go 23.98. Right, because this ends up getting really small really fast. Okay, so that looks pretty good. Okay, and then for C, we're going to want to do the same thing here. Use this geometric formula here. So the sum of the first 15 terms is going to be 15 times, and let's see the rate. We got -3. Oops, I should put this down here with where we're at. So we got -3 divided by 6 is -0.5. 1.5 divided by -3 is also -0.5. Right? So we get -0.5. Oops, I keep doing that, putting that extra parentheses in there. All to the 15th term minus 1. Right, and again, to make sure that I put this in the calculator correctly, I'm going to put double parentheses around that. And then all divided by -0.5 minus 1. Okay, so getting our calculator back out there again, we're going to do parentheses 15, another set of parentheses, -0.5 to the 15th power. Push the arrow over, so then we're going to just subtract 1 from that. Close our parentheses off, this inside one and the whole thing for the top. Divide by parentheses -0.5 minus 1. Close those parentheses, and we get 15.79 we'll go with. Okay, because again, this gets smaller and smaller and smaller, and it's positive, negative, so forth and so on. Okay? All right, last one here. And find the formula for this here, for the this series here to n terms. Okay, so for B here, again, this is -6, -3, so we know it's not, these are not arithmetic, so we got to use the geometric. So we're going to use the S of n. So the S of n is going to equal the first term, which is 12, all times the rate. So to figure out our rate, remember we just do 6 divided by 12, which is 0.5. 3 divided by 6 is also 0.5, so we do 0.5. Oops. 5 to the n minus 1 all over the rate, which is 0.5 minus 1. Okay, so really all we're going to want to do here is just simplify this as much as possible. So we've got 12 times, really can't do much in this top parentheses here, 0.5 to the n minus 1 all over, this gives us -0.5. So really, if we take 12 divided by -0.5, that's going to give us -24 times 0.5 to the n minus 1. So we can do S of n equals, let's see, ooh, that's not very nice. You know what, this is probably just easy enough just to leave it like that. Let's just leave it like this. Call that good. Okay. All right, well, let's call that good. I don't think we're going to need to do C. So if you have any other questions, please feel free to ask in class. Okay, thanks.